Okay, my friends, this is a very, very important discussion today about Earth's accelerating vibration. It's called the Schumann Resonance. And it originally is supposed to be steady at about 7.83 hertz. And until 3 years ago, it started to really ramp up. And it got up to 15, then 25, and then less than a month ago, this is 2017. It hit 36. I mean, that's kind of high. Now, I'm going to explain to you what the resonance is, how it propagates, and why this is of concern. Now, this is the first time in history, and that's a big deal. Earth is rapidly shifting her vibrations. Now, let's look at something else. Okay, this is just a little video. It's called Autopedia. Now, Audiopedia. Now, she's a robot voice, but you can hear it and listen to what she has to say about the anomalies that have been occurring within the last few years. Now, I've been reporting on this for several years now, and it just getting more and more of these anomalies, and I understand why. And we are being overcharged. Now, let's just listen to this.
Effects on Schumann resonances have been reported following geomagnetic and ionospheric disturbances. More recently, discrete Schumann resonance excitations have been linked to transient luminous events, sprites, elves, jets, and other upper atmospheric lightning. A new field of interest using Schumann resonances is related to short-term earthquake prediction.
The end. Now, let's discuss this. Well, there's all kinds of anomalies going on. There are things that they have never seen before, like this, Steves. Now, these are sprites, but there's also Steves, which are events that they're like flaky things, not like this. They're like ribbons that are going out. And then there's all kinds of things they're finding now. And, they were never seen before. The first one of these, I think, was 1994, but they're getting, they're not uncommon. They're not real common either, but they're not uncommon. Now, this is what happens. Somewhere in the surface of the Earth or in the lower cloud region, it's just too many electrons, and then they hit the ionosphere, which is nothing more than a layer that's right up here that is just 100% loaded with electrons, almost 100%. It's just totally slaughtered with electrons. Bam! When they hit that, it's like lightning hitting into all electrons, and because all the electrons are pushing back, they're pushing up, boom, and they try to absorb them. They try to infuse into them, and they say, no, you just can't get here. We just got too much. Get out. And they and they come back to Earth. Now, this is strictly due to overcharging of the Earth. And the more we have in our ionosphere, the more interaction with the scrubbing, the more heat, it drifts down. It's 56,000 degrees. Out here where it's scrubbing through space. That's the only reason possibly it can be that hot. It should be cold out there. It's not. It's 56,000. Around the sun, it's only 6,000, on the sun. 6,000 degrees. But out at the corona, way out at where it scrubs through space, because it's doing the same thing, it is millions. And let me just show you that right now, because I have a solar eclipse. Solar eclipse. There it is. All right. Here's what happens. The sun is behind the moon. All right. So the moon is eclipsing it. Now the sun is spinning. You can see it has its poles. Same thing as ours. This is where it's really scrubbing, and it's throwing particles off everywhere. And those particles are ether. It's just as simple as that. Here's the same picture. That's accelerated light. That's what we saw coming up. And when it hit the atmosphere up here, which is the ionosphere, totally different particles than down here. Down here you have gaseous mixture, molecules floating around. Up there you have a concentration of electrons. Well, that's just like hitting a brick wall to these things, because those are electrons. All right, so that's what we just saw, and that's what's happening with these sprites. And the only reason they're leaving the Earth is overcharged. Okay, let's talk about what the Schumann resonance is and what it's like right now. This is February 6, 2020, and this is what's going on in the field right now. Power 30 in the resonance. It's supposed to be around 7 or 8, right around there now. And it goes hour by hour, really. It's telling you after the previous spike, 28 it was, the movement's continuing between 15 and 23. To wake up, 14 hours of flat calm, and then chunked up to 28, followed by small oscillations, 30 at 6 a.m., 27 at 7 a.m., at 7 UTC. Now, it goes on and on about how it varied, and I mean, look at power 55. All right, power 40, power 47. You know, this is up there. Now, this is what's driving our weather patterns. I'm going to explain it to you in what I hope is enough detail so you understand it. Now, you can see these are very, very intense concussions of our outer atmosphere into whatever we're getting into. Now, why? Okay, this goes back a couple of months ago, but they've known this forever. Now they're just finally admitting it. Could the standard model be wrong? That's the Bohr model, and absolutely is wrong. It's been wrong forever. Now, here's what she has to say. Here goes.
Causality. Now, there aren't many different types of particles that make up matter. There are 6 types of quarks, up, down, strange, charm, top and bottom, and 6 types of leptons. 3 of these leptons are charged, 3 of them are neutral.
All right. This is where we got an issue, because they're wrong about all of this, because then they go from there up to just gigantic protons and neutrons. This is totally nonsense. What the truth of the matter is that everything is made from electrons, and I will show this in the light experiments, and it makes sense every single bit through. I can prove, well, I can't prove it, but I can pretty damn close. I can make more sense than anybody else, I can tell you that. I'm going to show that as a photon. I say that protons are nothing more than you would consider a big mass of electrons. And the same thing with neutrons. Now, they say it's got so many protons and so many neutrons, and they base them on the number of particles that are times an electron. And 1838, 1837 times the weight of an electron, approximately, for these two particles. So I say there is nothing more than that particle, and 1837 of them would be what this would be considered a proton. And there are certain values that are resonant frequency stable. That means that if you only got this many particles in that, it's not going to stay together. It's going to either add more or it's going to fall apart and get other ones. But then it adds more, and it becomes stable. Of course, it's going to be round. Anything added together is going to form a spherical shape. It just happens, and you can see it in the microscopes. It's not any mystery. Now, those particles that are in the outer regions of these atoms, and the atom is right in the center of this big ball, and then there's a bunch of little same particles that are in the big ball, but they're out here, and the big ball says, hey, I got enough in here. You guys can come around here. You can hang around. But I have like 2 volts I'm going to push you away from me. That means you're going to stay exactly right there because you have a certain voltage. I know how much voltage you have. It's called 1 electron volt. I'm going to push you away with 2 electron volts because I have so much in here already. I don't want you here. So you will stay exactly right there. You know, and you can float around outer edges, but you can't get any closer. And you won't go any further away because I will hold you there. And I will show you that in an experiment, a toy really. Now, that's what makes up everything. That's what a photon is. An electron is half of that, and we can break those in half. I'm going to show you all these things right now. Before I do, I'm going to explain to you what our solar system is and why we have magnetism. I mean, why we have gravity. All right, can you guys see this from here? Hold on, let me see if I can. Yeah, that's good enough. Maybe we can see it. I'll explain it. That's the Earth. Right? We all know everything slams down to the Earth. Okay, that's called gravity. Well, what is it? Why does it do that? Here's the reason. We all know there's a South Pole and a North Pole. Right? The South Pole is your negative side of the Earth, and the positive side is the North Pole. We all can see the aurora borealis that surround these poles, which are highly energetic particles in relation to the other particles around here, because this is where all these lines of electrons converge. They come around and into the South Pole. They go straight through the center of the Earth, up to the North Pole, back out around and back around this way. And the reason they do that is because we are spinning our negative atmosphere, which is all particles in our atmosphere, semi-glued to our surface through magnetism and gravity. So here we have a surrounding atmosphere spinning through ether. And you say, well, what is ether? Ether is all the negative particles that are being sent from the sun and every other luminous body in space, and eventually they will hit something and concuss. But between where they are emitted, which is our sun, and where they concuss, which is somewhere in our atmosphere normally, they are still there. They're coming, zip, and they have a mass, which is 0.005485 atomic mass units approximately. They have they are dipoles. They have a positive and a negative end. Only the negative end has power. The positive end is strictly a carrier. I'm going to explain that, and I will show it. They slam into our atmosphere from everywhere in the universe. Those are electrons. Those are particles. They have a charge. They have a mass. They invade everybody else's space. And what does that mean? Everybody else's space heats up. Not only the air that's in the atmosphere, but eventually that will transfer down into the soils, into the water, into the trees, into the cars, into the buildings, into the car, every single thing there is. Every single thing there is will absorb more and more and more and more until it can't absorb anymore. And that is where we are right now, my friends. We are spinning through this ether. See this, the right-hand rule? You spin this way, it means the negative goes this way. And it will create that every time. If you're moving through electrons and you're going to create an electric field, that's our magnetic field. Now, here's what you're going to take away from this. We have all this, our ionosphere is out here. Ionosphere means there's an area out here where we are literally coated with electrons. Coated with electrons, trying to slam into our atmosphere, which says, I got so many electrons right now, I don't want you here. We have sprites, we have jets, we have elves, we have Steves, we have things we've never, ever, ever, ever seen before, and they are coming stronger and harder. The weather events are absolutely untenable. I mean, they're just unbelievable, right off the charts. Now, and this is all scrubbing harder and harder and harder. So as it scrubs harder and harder, it gets more and more energy down here. We burn more and more fossil fuels and things, putting more and more electrons in the air. It has nothing to do with the C's and the O's. Forget that nonsense. It's all of the breaking of the bonds that liberate these electrons, and they're free now. They're free, and they're pushing every other electron away. Before they were locked up. They were all glued together like this. All of a sudden you explode them, and you got balls of them running around, pushing everybody else out of the way. All right, now, so let's just cut to the chase. Electrons flow through the center of the Earth. No question whatsoever. They create aurora borealis as they scrub through the electrons that the whole atmosphere is rubbing through. That's how you get your aurora borealis. Now, and you can see them come down in veils of these fields. Now, electrons cluster in and out of the poles. This is where the clusters are. Out here, they're not so jammed together. Down here, they got to force each other into the poles. And if you go on Google Earth and go over the top of the South Pole, it brings you right in like you go, it's very, very interesting. Like, it's almost like a focal point. Well, it is a focal point. Now, and it appears to understand that, or else they're veiling it, I don't know. Now, so it's going to cluster in and out of these poles, and therefore, I say it's likely going to be a warm spot. Admiral Byrd said it was warm down there. Now, and I trust him. I think he was honest, and I don't think the rest of them are being honest. Now, all negatives, anytime you see a circle with a negative through it, a line through it, it's a negative. And then, anytime you see three dots like that, it means therefore. It's just a scientific notation. Now, all negatives drawn into Earth ground. That's electronic symbol for ground. And everything is grounded. If you walk through the air and it's a dry time, that means the water molecules in the air are not able to hold onto the electrons easily. The extra electrons want to find water. You walk through there and you are a moist target for them. They jump onto you. You touch anything that's attached to ground, and it snaps from you to ground. That's static electricity. It's all it is free electrons. There's no other particles there but electrons. Zip, right to ground. Same thing with lightning. Zip, right to ground. Same thing with electricity. Right to ground. Well, guess what? Now they're seeing sprites leave the Earth. There's hot spots of electricity, of counter electricity here now on the Earth. Whatever the reason is. We're just overcharged in the atmosphere, and there's so much extra activity in the atmosphere. It's starting fires, it's starting tornadoes, and it pulls air from here and there, and then all of a sudden your cold gets pulled into where it shouldn't be getting pulled into, your hot is where it shouldn't be. They're mixing together, they're creating these violent interactions. You see them all around the world now, absolutely horrendous. And they're crushing the Earth. You're going to get more and more and more earthquakes. All of this is 100% related. All right, so where did I get to here? Gravity. All right, so that's Earth wants electrons, and that is all it is gravity. Gravity is the number of electrons sucked into the Earth. All it is. That is magnetism. 100%. The more particles in the smaller package, the harder it hits the Earth. If you got hydrogen or helium, they don't have enough electrons in the package that they're in, they go up north. They just go zip straight up. So that's gravity, done. Now, there are only electrons. That's all there is that exists. I've mentioned that. Those are the electrons. All right, and we can split them. I'll show you us splitting them. And they glue together to make photons. That's what light is. Now, so that's that. Now, half of it is the carrier. The black part I showed here, the black one at the bottom is the carrier. The red one is the powerhouse. So half is a carrier and half is power. One of them is the power, one of them is the carrier. The white one will explode like an atomic bomb. The black one just walks away. So now, all free electrons are ether. Right? So if the electron is not attached to something as a part of a particle, it's free. It's free to move as heat, as electricity, as static, as all of these interactions that we see. Heat is nothing more than forcing these free electrons that are ether, and the ether is in everywhere. There's ether in this paper. There's ether in this screen. There's free electrons in every single thing, otherwise they would not transfer heat. Now, so there's ether everywhere. Now, Earth spins its electrons that are coating the Earth into all that other ether, which is all more of negative particles. That creates a generator effect. We are just a generator creating electricity. That's all we're doing. And which is our magnetic field. Earth is overcharged at the moment. We have scrubbed so many particles, and they collect. They don't all trail off and spit off into space. No, they have overheated, and the only reason everything is overheated is because we have accepted too many electrons. Now they want to push back out, and they are in these anomalous events. And with what she's going to say out here somewhere, 3 something, I think it was. Yeah, let's see if she goes.
There's still a chance, a small probability, 1 in 100, that what we're seeing could just be a fluctuation from B mesons decaying to electrons and muons at the same rate.
No.
So in order to be absolutely sure, we're going to have to analyse more data to get that final significance. But the reason why this is so interesting and thrilling is that, besides being unexpected, this could genuinely be the first sight of something new. Because if, when we've analysed more data, this difference between muons and electrons stays and lepton universality seems to be violated, well, what that means is that there's something wrong with the standard model. We found the crack, finally, in our understanding of particle physics. There's absolutely no way that we can explain this observation with our current understanding.
They never could. They never could. Lanthanum has 38 isotopes. 38 different particles could be called lanthanum. Hydrogen has 9. Sulfur, I think, has like 18 or something like that. I mean, they got a ton of different particles that are all called the same particle. Because in between every one of these particles, there are literally thousands, and I mean many thousands, of electron components. All right? So when they break down, they can break down, not in a big chunk has to go away, half of that chunk could go away. One of these could go away. So when they do their work at CERN and they blast these things into atomic bomb bits, they have no idea what they have. All they have is a bunch of goop laying all over everything, and they dig through it and they say, ooh, well, that spin like this, ooh, that span like that, and that went this way, and well, we're using electrons in our experiment, not photons. I mean, we're using photons, not protons. We're using the tiniest particles that exist, and then we can even make them smaller than that. Okay, here it is, my friends. I've shown this dozens and dozens of times, at least. Now, in this particular group of pictures, you will see that not a single physicist is correct now or has been correct since all of the top physicists came along. This is red pulsed laser light. Very simple red pulsed laser. These little particles here are the ether that I talked about, and they are all over here, they are everywhere. Now, what happened to this wave? Well, it's coming through the air. It looks like just a wave. Well, guess what it's made of, actually? It's made of a particle. All right? The particle itself comes through here. And it is now accelerating, and the reason is because there is a Venturi here, which is 2 round cylinders, that light has to accelerate to get through, and it sucks everybody else along with it. It creates plasma, and these what they call interference patterns, which are not interference patterns. This is a single slit, so they're not flapping back and forth through 2 slits. This happens strictly due to the fact that these are all negative particles and they do not want to be associated with each other. As they come, they set up a line of particles that stay in line and push the other ones into the next line. That's what causes this. And the particle is spinning, so some spin off that way, some spin around and come off this way. Now, let's look at what they do when they come out the other side of this. And this is going to be your Higgs fields. All right, and now I'm going to show you what CERN's looking for, because that's what they're looking for. Only they're looking for them out of their heavy particles, but hoping to find what we show here in the light particles. Now, we had one come through as a reverse spinner, and it hit another one of these fields and did that. That is smaller than light in my world. Now, this is the actual photons, and I showed you here on my... That's what I say is a photon, right there. That's another photon. And the reason they're displayed here is because this is just shortly after the accelerator. There's a spike coming up here and a spike coming up here. And we see these in green, we see them in red, and I haven't seen them in blue because I haven't seen blue particles like this. Although I have seen this here now. But anyway, let's just stay with this. These particles here are like 2 electrons, one this way and the one that way, glued together, back to back. That's what I'm seeing. And then when we really concuss them, we can force the black ones just to walk away from the white. But the white does not stay silent. let's go with that. It goes crazy, and I will show you. Okay, this is electron neutrino. I can go into this deep, but I'm going to stay right on the surface. High-speed electron, just like I showed you after we accelerated it, crashing into space, which is ether, because it's all these particles, just like all these little dots would be ether. And boom, it does this and creates these electron showers. Well, these are supposed to be very, very unusual. I can give you bucket loads of them. All right, you heard the woman say that the Bohr model is totally wrong. She's right, it is completely wrong. You saw these particles, the photons. I say that that's an electron, and I say that these are a charge carrier, and that's an explosive particle. Here they are right here. You see the little black dots? You see them all over, all just black dots. There's no big explosive black thing, no big blob of blackness. You see the white? You know, they came through here, and it started to concuss. So we saw some white start to, but once they reached this level, they said, that's it. We all have to force into each other's regions. And if you look up the 21 centimeter line for hydrogen, you will see that they own huge, enormous magnetic regions. And when they are all being driven together into this, they cannot stand that, as is witnessed right there. Now, that's charge separation. All right, the carriers, which they call the gauge bosons. A gauge boson is supposed to be a charged particle carrier. That's what I'm seeing. I see a little black thing saying, come on with me, white guy. And he said, okay, where are you going? I said, well, I don't know, we're going to go down there and explode. So you go in and explode. I'll hang out and I'll meet you on the other side. That's what happened. Once these white guys try to get together, forget about it. The black particles just drift out and get out of the way. So you got your strong force, you got your weak force. Black and the white. You know, and not in that order. The white is the strong force. The black is the weak force. You have particles, which are, as Einstein said, nobody knows what they were. They're particles. They're not with waves and so forth. Now, so they're particles. They spin, and I can guarantee you they spin, because I can show you that too. They can charge separate. They are dipoles. All of these things have just been seen. Light accelerates. It's a particle. It's a dipole. It can charge separate. We've seen the gauge bosons. We've seen the fermions, which is the white portion. We've seen interference patterns are not created by overlapping waves from two different slots. Absolutely not. So anyway, 100%'s been wrong about everything is what it boils down to. That's the bottom line. Einstein was wrong about everything. Hubble just said, I have to say that everything is going away from us faster, because Einstein said light can't shift red. Well, he's wrong, so now everything is moving away faster than the speed of light from us. That's what it boils down to now. You know, I mean, everything was predicated on the absolute most ridiculous nonsense that made it so you couldn't even figure out how gravity works. I mean, it's been, oh, there's a big mystery. Oh, gravity's such a mystery. It's just the most basic, obvious thing if you can accept ether, which they pulled away. Oh, there's no ether. There's none of this. There's none of that. No, 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 no. And then once you get a guy that thinks he's a hero and everybody thinks he's a hero and everybody points to him, that's it. You're done. You're done. Absolutely done. Because nobody can stand up. The only reason I can, because I don't care. None of this matters to me. I don't care about any awards or any books or any job titles or any of that stuff. What I care about is seeing reality. And I finally saw it. I'm starting to maybe breathe my last breaths. Who knows? I just wanted to get there before it happened, and I think I got it. I hope you guys can get it too. A large hadron collider explode in gigantic particles everywhere. Same spinning particles and all that stuff. Exactly what I'm showing. Only what I'm showing is light. They're showing things that are like 8,000 times or more particles than I have, and it's just making a big mess. So I think the little particles would be the way to go. All right, I told you light spins. Well, that's through the same thing, through that same single Venturi. The light is spinning, and it spins this way. You can see that it dives behind, and it comes out over here and back in around here. Now, some will come this way and in, and then it comes in around this side. All right? So it'll come over and in, or it'll come under and in. And these are the patterns it makes. There are particles that want to stay away from each other. Now they're red back here because they have shifted back from their extremely accelerated white, which is still accelerated in the center. But on the outside, they've brought themselves back to the white. All right, I get into the fact that you can accelerate the particles, because I'm telling you, these are all the same power. They're all the same particle. They're coming out all the same from the red, the same way. The only reason that one turned blue is because it got crushed from the sides. That means you can increase the potential, because now it's dropping back to its red state. If you can see that over there on the side. Now, these are the Higgs fields. Now, what does that mean? Okay, here's what it means. Coming through the Venturi at us, the tiny zzz, boom, and it hit the ether. Well, this one wasn't spinning to the right, which it should be. It was spinning to the left. That's what I'm saying. Now, I could be wrong. I think it happened once before, maybe. Not sure. Now, these here are these Higgs fields, and you can see every now and then one will get crushed a little bit different, and it'll change a little bit of a color, but I've always seen them come back to their red. So it doesn't change their color and they stay changed. It squirts them out ahead and they change colors that way. But anyway, this is the one we're concentrating on now. Why is it white? How come that one's different than everybody else? It came through the Venturi the same way, only it didn't actually come through the exact same way, because once it came out of there, it did this, which, as far as I'm concerned, I'd like to have a CERN explain this to me, or somebody, because that's their little white particle. These are our normal fields. I don't know what you see, but I see that particle possibly transitioning into one of these particles. But what is that? Is that it's extra energy? Will this make one of these? Is it an antiparticle? Well, it's pretty powerful. Came out of there like a little lightning bolt. And now, is it spinning because it's, you know, there's so much to know about that. And nobody's going to know about that, because the only one that's going to be able to recreate this stuff is Rod Warren. Don't come to me looking for experiments on this. I explain what he has done. I have other people that did the same experiments, and they came up with similar results. Nothing like what Rod has. Rod is the master. If you want information on this, he's the guy. Now, he's a little hard to get a hold of. I mean, I milked him dry. I mean, I did. Rod was so good. And I hope he gets his just desserts on this, because without him coming up with the Venturi, there's absolutely nobody in the world would ever have any clue about this. And without me seeing it just by accident, it would have just been wasted. You know, not wasted. He had a good time doing it, but nobody would have understood about this that I can think of, because they were giving him a hard time. And I think that's why he withdrew, to be perfectly honest with you, because I know what it's like to get a hard time. All right, past that. Rear view mirror stuff, as they would say in the Senate. Alright, if you're watching this video, you must be at Mudfossil University, so I would come up here and look at these academic review of dragon carcass. 2 minutes and 28 seconds. Very interesting. A lot of stuff about life in our ancient past. A lot of things about space. They found it's literally 100% organic. The new particles I showed. This goes pretty deep. We have a lot of research here for you. Now, things are not as advertised, my friends. It's time to stop and gather as common cause and look into this together, because all of us people that are outside of the organized domination of education, we are disregarded as insane people. And you know, there are some. that's no question whatsoever. But what I am showing is factual, and it's certainly deserves debate. All right, thank you, and God bless you.